Logs will be on your next test again. It'll be at least half logs that you have. So, for those of you who still haven't figured out logs, we'll try and refresh you on it every single day. Because they're still important as far as I'm concerned. Right, the inverse of f of x is 3 logs 2x minus 1 plus 5. How do you write an inverse? First step. Swap x and y is first step. F of x is y, so what does it become? It is y. It becomes x. And every x becomes a y. The log is bay is the idea eventually, but this one's a little harder. Is it ready to become an exponential function? Not even close. What's the easy thing you can do? Minus 5. Should always do whatever's easy first. Is it ready to become an exponential yet? No. Why not? There's a 3 out there, and you're supposed to isolate the logarithm. How do you counteract that 3? Divided by 3. Save myself a line. I'm just going to erase it. There we go. Tanner, what's the understood base of a log? No. 10, that's right, Melanie. You don't know, what do you look at? Look at your calculator. For some reason, you can't remember the understood base of just a log. It's 10. You look at that TI-84 and you look at that log key. Don't act like you don't know. Look at it. It's there. There's a 10. Oh, yeah. Yeah, right there. There you go. Log is what? Okay. Those of you that are struggling on logarithms, it's probably that you're not remembering this. I can understand kids not liking logarithms. I can get that. But believe it or not, you're getting a really good instruction set on this. Log is bay is equivalent to what?
Base to the exponent, or e equals a.
You can look at that little ACT book you got, and they don't do log is bay. They do, oh, I saw it the other day. It uses x and y and some other letter. I think it's b. I think they do log base b, x equals y. The little ACT book, practice book you got?
I'm sure they do.
They don't do log is bay. They do something else. Anyway, she's ready to become an exponential. As an exponential, what's her base?
10.
10. Because they line up. What's her exponent?
X minus 5 over 3.
X minus 5 over 3. And what's she have to equal?
2y minus 1.
2y minus 1. Still got to solve for y. What's the easy thing?
Minus 1.
Minus
Or plus 1.
Plus 1. Don't be that kid who's just waking up and decides that they can add 1 to 10. Why can't you?
Because 10 has an exponent.
Because 10 has an exponent. It's not really 10. It's a base of 10, but I don't know what it is. What's the next step? Divide by 2. Also, don't be the kid that thinks you can divide that 10 by 2. Why not? There's an exponent. Don't do it. It's not the same. 5 to the x minus 5 over 3 is not the same as 10 to the 5x minus 5 over 3 over 2. Not the same. Now, once you've isolated a y, how are you supposed to rewrite it? Read the inverse of f of x. Great note taking. Amazing. All right, moving forward. Part B, solve for x. Leave your answer in perfect form using change your base. So no cheating in the graphing calculator. No cheating with graphing calculator. In fact, I don't even want to know what the decimal is. Don't care. That's an exponential equation. What are you supposed to turn them into? Logarithms. How?
First, you gotta make the
Isolate. Isolate base. What has to be added?
Plus 5.
That's 5. No extra credit this 6 weeks, kids. she's ready to become a logarithm. You should be able to identify the base. 4 to the x plus 3 is 12. What's the base? 4. I know some kids can't. I've done this for years. It has a base of 4. What's her exponent?
X plus 3.
Plus 3. And what's her answer? Well, when you write as a logarithm, what's your base?
1 base 4.
1 base 4. The argument is the old answer.
12.
12 must equal the exponent. Plus 2. Plus 3, yeah. One step and it's solved. Minus 3. Now, why do you think I mentioned using change of base? It's technically solved, isn't it? Why did I mention change of base? Because somebody decided that ln over ln was further than that. That's why. It wasn't me. Rewrite it using change of base, which is another thing that killed some of y'all. The last question that test you took was supposed to be the easiest. It was not supposed to be missed, but it was. Log base b to the a, how do we write it as a quotient of 2 natural logs?
ln A over ln B.
ln over ln, what's high is high, what's low is low. ln A over ln B. So, rewrite log base 412. There you go. Not in the fraction, that's right, because 3 is not a logarithm. Like I said, I didn't decide this. Somebody else decided this. That looks better than the original log. I don't know why. Don't care why. Just what it is. There's something old. Next set of notes you have, we'll do some more logarithms. I hate wasting time on it, but several of you all don't understand logarithms. All right, moving forward, this is 8.1. In that 8.1, you're going to do 2 things. You're going to graph simple rational functions. They are simple. And probably what we'll do tomorrow, we'll start talking about today, but tomorrow we'll be doing what's called analyzing. Analyzing a graph like that. Ultimate goal, write its equation. Yeah. I can do it.
It's not hard. Well, usually those are hard. It's just time consuming.
Anyways, here's a key concept, new mom function. I think she's number 9 on Friday's quiz. The parent function for simple rational functions is f of x is 1 over x. Ratio, kids. Comparison of 2 or more things. It's going to be a fraction.
Oh, like
Yeah. Same way. I'm only going to make you memorize 2 key points. What happens when x is -1 and what happens when x is 1. If x is -1 and you plug it into 1 over x, you get -1. If you plug a 1 in, you get 1 over 1, which is 1. Those are 2 key points you have to memorize. The rest of it is shape. Kind of hard to do with your hands like some of these. That's what mom looks like. And that's what all the simple children look like. The ones that don't roll too far from the tree. All right, there's 4 things to describe her. Some of her attributes. What's HA stand for?
horizontal asymptote. So
Where is it?
0.
Yeah, say more than 0.
Y.
Y equals, it's right here.
Y equals 0.
I've told you guys for a long time, if you just say 0, it's wrong. There's an equation of a line. That's what it is. It has a vertical asymptote. Where's it at?
X equals
X equals 0. It's vertical. All verticals are X. It's right here. Let's do domain and range using set builder. Set intervals. Set builder. Set builder is where you got the curly braces. It's easier. Remember how that reads? X bar, what's it mean?
X is everything such that.
All values of x such that, that's close enough. All values of x such that. What's the one thing x can't be?
0.
0. It can't be an asymptote. There's an asymptote of 0. Close the curly braces. Range all values of y such that y cannot be 0. Now anything that is that simple in form is going to look like that.
What are they supposed to like actually represent though?
You want me to give you a real life situation of that?
Yeah.
I'd have to look at that. I don't know anything off the top of my head.
Okay.
This is simple. This is a building block. The main thing of this graph is basically to introduce that stuff, the concept of the asymptotes. It's a building block stuff. All right, graphing rational functions. Y equals a over x minus h plus k. That is the transformation for mom. Anything that looks like that over here is a child of 1 over x. So it's going to behave like 1 over x. It's going to have asymptotes it can't cross. And it's going to have the same overall shape. I'll try and teach this as easy as I can. There's the steps in there. Most important one's probably the last one. Check with the calculator. Number 2 is a big one. Think about mom. What do you guys look up, 1 word at a time or something?
Yes.
Usually,
I was working on
maybe 2 letters.
D R.
Here's your first child graph. Y equals 6 over x minus 3 plus 4. Based on what you've seen in the past, and of course based off those instruction sets, what does this mean to you?
X minus 3.
It means write 3.
Yeah, that's
It also means add 3 to x. It also means that. Because if you're shifting the graph right 3, what are you actually adding to x? 3. What you're doing. How about that plus 4? Up 4. Anything else it might mean?
add 4 to.
Add 4 to y. There's this guy over here too. It still gets to be something it's always been, ironically enough. What's it always been?
Slope.
Initial slope. It's kind of a slope deal. It's your scale factor, it's your stretch. But you can still treat it as initial slope to some degree. What it actually does is it multiplies y by 6. What it actually does, it's done that the whole time. I don't know if I've ever pointed that out or not. It's a multiplier on y values. So lots of little things going on. Let's do those shifts right and up If you do the shifts right enough, you get all this stuff down here for free. Right 3, up 4. That'll tell you where your vertical asymptote is, where your horizontal asymptote is, where your domain and where your ranges are. Look, where's the horizontal asymptote? Mom was unable to cross her horizontal asymptote. Therefore, the child cannot cross its horizontal asymptote. What's the one y value it can't be? 4. Since mom couldn't be 0, the kid can't be 4. All values of y such that y is not 4. The vertical line there. What's the equation for the vertical asymptote?
X equals -3.
Positive 3.
Oh, right.
Can you cross vertical asymptotes? Nope. What's the domain? Sounds good to me. That's all little stuff. Now time for the big stuff. I'm going to think about mom here in a second. I want to make sure you guys all have that down so I can erase it. So that's where I'm going to draw mom. And I'm going to explain this, the nitty gritty, so you can actually see all the manipulation, and then I'll try and point out the easy way, okay? Mom has a point, 1, 1. She also has a point at -1, -1. You guys remember PEMDAS?
Yeah.
Please excuse, multiply, divide, add, subtract. There were 2 things there that required adding. There was 1 thing that required multiplication. You took the notes, right? What are you supposed to do first? Multiply or add or subtract? You're supposed to take the y values of mom and multiply her by what? 6. So, we multiply y by 6. That ordered pair becomes -1, -6. Because I'm only 6ing the y values, what's the second order pair become?
1, 6.
6. Multiply the y values by 6. Then there were 2 addition operations. It doesn't matter which order you do addition, does it? Never has, never will. I think we had to add 3 to x. So I'm at -1, -6. If I add 3 to -1, where am I? 2. No change in y. If I add 3 to 1, 4. And there was one more thing that's supposed to be done. Add 4 to y. This is probably the longest way, but at least you'll understand why things end up working the way they do. Well, there will be no change on x because all I'm doing is adding 4 to y. If I add 4 to a -6, -2. If I add 4 to 6, 10. Those are the 2 points on the child. The child has those 2 points. I go right 4 and I got to rise 10, 5, 6, 7, 8, 9, 10. It's down off the grid. It's up here somewhere. I got to go right 2 and down 2. Down there. Now, this was mom, again. One of mom's points was 1 unit right and 1 unit up, wasn't it? This point right here is 1 unit right of the new origin and how many up? 6. 6. See that? This point down here is 1 unit left, just like this one is. And how many down? 6. I hope you caught on to that, because it's a whole lot easier than doing all that little math, isn't it? You still get to use that as some concept of slope. It's telling you to rise and fall. That's all it's telling you to do. Most of the graph is going to be the same, except you're going to have more separation between mom's graph and this new origin. If you don't believe me, just go look on a TI-84 graph. That's what she looks like. Lots of fun. The reason I'm teaching, I didn't teach this last year, and the dual enrollment teacher told me that her kids did not understand rational functions like they were supposed to. I cut it out, thinking maybe I could cut it out, there wouldn't be much harm, but the dual enrollment teacher told me otherwise. So it's back, and you're welcome. Because it wasn't for me, it was for you.
Okay.
I'm just worried about your future. All right, some slightly harder stuff. The goal here is to figure out a little bit about a different form. I'm not going to teach you how to graph that thing. If you want to know how to graph it, you plug in numbers from -10 to +10. Wouldn't that work? Of course it would work. Isn't that how they taught you to graph when you were in 7th grade? Plug in numbers, plot points, connect dots. If you want to know how to graph that, do that. But I do want you to graph in your TI-84 this equation when you change that to a 5. -15x minus 6 over 5x plus 10. Oh, I lost it. I had it open and I lost it. I did too much of your homework today. That's the graph you need. We're going to finish this slide, kids. This is the slowest class I've had all day. Fifth period got all the way to slide 8. So, a couple of you guys probably aren't getting the same graph I had. I did not use that fraction key, but what I did is I saw 2 or more things and I wrapped. That's commandment number 9. If you don't know how to get to that fraction key, by all means, you can for sure learn how to wrap. You get the fraction key by going to math. No. That's what you do. You don't even have yours on. Neither do you. You're not looking at the graph. Not at all. There's a typo somewhere. I did. It's supposed to be a fraction.
I know.
Time for your y1 and
Right.
y2.
I did a fraction after it. I did.
No, not barely. Don't know how to get to that fraction key, kids. You can type it in the way I did. Sorry you hate algebra 2. It ain't my fault. Not. Algebra 2.
Good afternoon. We just have a few announcements. We will have sitting in the theater during directed studies, and these following students need to go to the library: Jillian Melton, Brianna Washington, Haley Wise, Sophia Leno, and Mark Maddox. Thank you.
Hi, Julia.
Hopefully you guys have a graph you can look at now, and hopefully you figured out how to graph. Let me do some mighty fine doodling, by the way. Anyways, from this graph, you're supposed to be able to pick things out. That's part of the skill, learning how to pick things out by looking at a graph. There's something going on right here. You can see it on yours. Sadly, you can't draw on yours, but hopefully you can figure it out. Something's happening right there. Are you ever crossing that unseen line?
No.
What do you call that unseen line?
A horizontal
A horizontal asymptote. Maybe you can look at yours and see it, but it's at y equals -3. Is there a vertical asymptote present?
Yeah.
Right here. Where is it?
X equals -2.
X equals -2. What I'm trying to do here is establish something. There's a relationship between looking at an equation and what the graph would show you. Part of your standard is to look at a graph and analyze, and part of the other standard is to look at the equation and analyze. All right, both ways. Now, I've got written here for rational functions the form y equals ax plus b over cx plus d, the horizontal asymptote is at y equals a over c. That's picking on these numbers right here, if you can line up with that form. And if you do -15/5, what do you in fact get? You get -3. Y value would be -15/5, which is -3. Horizontal asymptotes happen when you don't pay attention to the second commandment of math. Second commandment of math.
Shop, divide by 0.
Vertical asymptotes happen when you attempt to divide by 0.
Okay. That's cool.
They were introducing this concept, you guys, when you were in 7th and 8th grade, and they told you the slope of a vertical line was what? Undefined, which is exactly what it is. Divide by 0 is undefined. And we already had this lesson here. If I want to know what x value is undefined, I know I can't divide by 0. What do I say is not 0?
The equation.
What part of the equation? By the bottom. The only place division happens. So 5x plus 10 cannot be 0. That's a two-step equation that anybody ought to be able to solve.
So
Subtract
CX
10.
plus B can't equal 0.
Yeah, if you want to use that, that's fine, but it doesn't matter. What can't be 0? The bottom.
The bottom.
This will tell you that x can't be -2. It's kind of funny we write that the asymptote is at x equals 2, but then we say we can't be -2. It's because they're the same thing. Because can you cross vertical asymptotes? No. That's why they're the same thing. And that was the slowest of all my classes today. And that's all we're going to do. Mostly Chris's fault.